the main screen here. Right now, we have a place where we can look at the current RPM and time and the actual viscosity. So this will graph as we measure. Right here, you would see the current live dynamic viscosity reading, your current RPMs, your current runtime, the current temperature of the PT-D80, and your current torque of the instrument. So those are the main things you'll see here. If you need to change the temperature of the temperature device, you can come here where it says set temperature, just hit it, change it as needed, hit OK, and you're done there. Over here, we have a favorites bar. So if you had any warnings or errors, you would see that here where this check is. So right now we have no warnings or errors, which is good. Over here, you would see your spindle information. So when we do connect to the spindle, it will automatically show us all the information of the spindle. So it knows that already. It's imported automatically. The spindle and the instrument have RFID chips, and all of the information for that exact spindle is saved on the spindle's RFID, so the instrument can read it off of there. The spindles are also magnet coupling, so when you place a spindle onto the device, it's just going to magnetize. There's no screwing or fidgeting with it. There's essentially no really wrong way to add your spindle, unless you're trying to stab it with a knife and then you might break it, but I don't think any of you will be doing that.
It kind of clicks in automatically.
Yep. And
you can feel it, the magnet will just click it right into place.
Exactly. So down here is your PT-D80, and you can see this is where your cup will go if you're using cup and bob. It is possible to run without the temperature device. We do have additional spindles here in the back. I'll pull those out really quick so that everyone can see those.
So the spindles you just use with like a beaker of sample.
Yes.
Right? You don't need anything fancy.
Exactly. So if you were to use these just regular spindles, they are just, these spindles here are just run with a beaker that's 600 milliliters with 600 milliliters of sample, I believe. So, or 500 milliliters.
I think it's 6.
It's 6, okay. So you'd use maybe a liter beaker and then 600 milliliters of sample if you were to use these. However, if you are able to run, if you need temperature control, you have very low sample volume available or something like that, then you could use, you guys have 2 cup and bob systems. We have a CC12 and a CC18. So that's a closed cup. And here is actually this right here is actually your cup. And then the bob is in here. And so you can see right there, actually on the top of that spindle, there's your RFID chip.
So that's what automatically detects it. So we'll see that on there. When she clicks it on there, it'll come up on the screen and say you're using this bob.
Yep.
Okay,
So
it's got its own serial number, right?
Yes.
Okay.
So here is what that bob looks like, and now we'll go.
Why would you use this over a spindle? Because to me, it's easier if I can just go in and grab a spindle and a beaker and go in. I'm using this because I'm using the temperature, right?
You would use this versus these. The main reason is if you have limited amounts of sample. So if you don't have 600 milliliters available, and I think this is somewhere. This is 2 milliliters versus 600. So that's a big difference. Yeah. And this one I believe is about 7 milliliters. The CC 18.
Okay.
What is it?
We have a question kick in. Actually, ask what's the smallest volume? Is that 2 milliliters? Is the smallest volume we can measure?
Yes, 2 milliliters would be the smallest volume you guys have with your current setup available.
Okay.
If they got something, is there something available that can get smaller?
I think 2 is as small as we can go with this instrument here. You will also have a Rheometer purchased. So this guy is just for quick, simple, easy viscosity measurements, not rheometry.
Okay.
You know, so if you need a really, really small measuring amount and you need your actual rheometrical values, then you would probably go with the Rheometer and measure that there. So this guy, if you can just run it straight and get a viscosity measurement, or you can set it up to measure viscosity over periods of time, and you can set exactly what those times are, or you can let it do it in a table. You can also set it at different speeds in the same way and different shear rates in the same way. So if you just enter one number, that's easy, done. Or you can go into it and really go in depth of how you want to measure things and see what tables you would like to see in that way. So the first thing when you turn on the instrument, you'll see this screen and it'll say level adjustment. So we want to make sure, of course, that this guy is level. So you would just move the feet here on the bottom of the instrument. They spin back and forth here until we get that dot into the center of there. And if it were to be out, like if I were to tilt this a little bit, it'll go yellow and then it'll go red. So you know you're good when it gets into the green.
Yeah. So that's pretty nice because it's automatic, right?
So after you finish your level adjustment, it'll go ahead and do a 0 of the spindle. So it'll ask you to remove any spindle if you have any in there. We don't have any spindle. I'm just going to hit next. And so now it's just going to do kind of a bearing check of what 0 torque is like. So it said don't touch it.
Okay, yeah.
So we got our 0 adjustment. It'll tell us how much it was offset via the last adjustment there. Looks good though, so we're going to go forward. And then it'll also ask us to level the PTD80 itself, which is the temperature device here. And so you would just do that with these 1, 2, and then 1 in the back feet. And so when those are good.
So you get this leveled, and then you get this leveled, right?
Correct.
And then they're both going to give you a green dot.
Yeah.
Okay.
So that's what will pop up when you first turn on the instrument. Okay, great. So let's go ahead and actually begin running a sample. And just to let you guys know, we haven't run anything yet. So this is going to be the first actual sample this instrument's ever run. So if we run into something, we'll just work through it. But hopefully we won't. So here is the cup. And I'm going to take this little adapter piece here. And you'll see on it that there is this little hole. And that little hole is going to hit right here.
So it's got locator pins.
Yeah. So this side's going to be the bottom on here. And there's also a little tiny
and that
this
clicks
screw.
into place.
Yep, and then that screw is going to go on there. So I'm just going to kind of.
The bearings kind of click it right on.
Yeah.
So you can hear it click.
So there's that.
Yeah.
Another question, that's fine.
I can.
No question.
Okay.
That's all.
So now I'm going to. So I don't know if they can see this in there, but inside of this cup, I don't think they can see it.
There's a little
There's
line.
a little line. So I'm going to fill the sample to that line before I put the bob in. So I think.
Do you have to be exactly on that line or just kind of close?
You can just get close. This is the old Brookfield standard. It should be around 28.10 at 25 degrees Celsius.
Okay.
So the first thing we're going to do is, usually when we have a method, we would know what RPM, what speed we need to be running at, and approximately at what the proper torque. You know, to what speed do we need to run at to get a proper amount of torque. So I don't know what that's going to be yet right now. Or we're going to pretend like we don't know what it's going to be. So I'm going to run this in what's called true mode. So it's actually going to run and kind of shift around at different RPMs and try to find what is the proper RPMs for this specific viscosity sample. So that's what I'm going to be doing here. So I filled my sample, the cup is ready, this is on there. I'm now going to put my bob into here.
So you put before you even do anything, you're just putting that bob outside the instrument, just putting it in there.
Yep.
Okay.
So I'm actually, and so over here too, I don't know if we showed this earlier. This is on the side of the instrument. You can make the whole head go up and down if you want to pull back a little bit. So the head travels up and down. So I'm going to pull the head up a little bit higher than I need. And I'm going to take my bob, place it in there, right where I need it to be. So that clicks into place, so it's sitting there. Now I'm going to lower the head. Until it gets So it will align itself to where it needs to be. Let me see it here.
So there it is. You could hear it beep.
Yep, so if you guys didn't see that, I'll do that again for you. So my bob right now is in there. So I'm just going to disconnect my spindle. It's just a magnetic coupling, so now it's unhooked. And now I'm going to hook it again. Oh. Boop, done.
And then that little beep says, hey, we see it.
Yep. So I'm going to come over here where I mentioned you can see the spindle spec earlier, and now it's showing us that there is something there. So we'll hit it, and now I can see that it's a CC12. These are our current spindle specs. You can see the number for it. You can know that it needs a DIN adapter. So we have all of those things ready. Looks good. So let's go ahead and try to, we're going to run in true mode. And true mode is what I mentioned is how we're going to attempt to allow the instrument to automatically find the correct speed for this. So I'm in true mode. I have my temperature set. I'm just in manual mode. So what I'm just going to do, I'm just going to hit start, and I'm just going to watch it run until I see the speed just about stabilize, and then whatever it kind of gets to, that's where I'm going to go for my next run. I'm going to enter that speed in. So let's go ahead, and I'm going to come in here and hit start.
Okay, so what's this telling us right here? What is that?
So right now it's just telling us that we're getting some kind of viscosity. So those are our RPM, so we're just kind of slowly going up in RPM.
It's going faster.
So yeah, if you can see in there on the camera. You can see our torque percentage here. I think we're going to try to get to 80%. So now we're getting an actual viscosity reading. We're running at, yeah.
It's spinning pretty fast.
Now, can you see the spinning clearly?
Yes.
Good.
Yeah.
Okay.
So we're spinning at 250 RPM, and we're getting a viscosity reading of 28.4 millipascal seconds at the moment, and we should be around 28.1. So
That's right there.
yep, I'm pretty happy with that. So we're close already. So that's good.
What's going to get you closer? What are you trying to do?
Well, we're gonna watch the speed if it needs to readjust the speed in any way, but it looks good. I think if we go ahead and we can see that it's running at 250. So I think if we were to stop it, and everything's stabilizing, like it's not shear thinning, it's not shear thickening. So if I were to stop it now, I'll go ahead and do that. So essentially that's what true mode does. It just ran, gave me a speed, it was constant, I looked at everything. Some samples are not going to be that quick. Some samples may take a couple minutes, like it depends on what it is.
Okay.
So I'm going to go in here now. So now my result that I've stopped it. Not all of your measurements you will have to stop on your own. I stopped this one because it's manual mode and because that's what we were trying to do. So some methods and certain samples will stop automatically after they get a stable result.
I see.
So you won't always have to be here standing here. Some things you can start, walk away, and then come back later and see how it turned out. So the results of that last test was on this screen now. And so I'm going to actually go ahead and rerun, not with true mode, but with set speed, and I'm gonna go put it to 250 RPM. So now it's frozen on the screen here. I'm actually gonna come over to monitor mode. So this little button here that's a monitor with a little refresh arrow, that'll go from the last measurement result to a live blank reading. So now I'm gonna come here. This is our speed editing place next to temperature. So I'm going to hit this little gear, and I'm going to hit set speed. I'm just going to say 250 RPM. And
it needs that to calculate an accurate measurement, right?
Correct.
Okay.
Yeah. So that's what it used to get a good measurement with true mode. So now we can go ahead and move forward with that in there. We know it now. Let me see if there's a better method I can use too. I think I might just stay at manual, but
If So what happens if I don't get that speed right? My viscosity measurement will be off. That number will be off.
It depends how wrong you are.
I can be pretty wrong.
Like miss a zero.
Yeah. You might, I mean, for your torque might be, if your torque is showing not around, like and I'm not the most rheological expert, you know, I'm really on the viscosity side, but if your torque for this guy isn't around 80%, it's not really great. If it's too high, if it's above 90, or if it's below 10%, it might not be good enough.
Okay.
So,
So we got the set speed. We got the set temperature. Did you do anything to set that temperature? How'd that get?
The
correct?
temperature was actually, that was what it turned on at 25, but if
Okay.
you want to change your temperature, you just hit it, tell it what you need.
And what can we go up to?
80.
80. We can go up to 80. Okay, so we got the speed, we got the temperature.
Mhm.
What about torque?
So torque will, so it's going to set itself.
Okay, gotcha.
And we know that that speed can get us to that correct torque.
Okay,
So,
and this is what I did when I was running it. I just made sure this was a green check.
Yep.
And this was green.
Yep.
So it's all, if this was wrong, it would give you a little exclamation
Yep.
right there.
Great.
Great.
Okay, so now what do? You hit start.
Yeah, so now that I have this, we're gonna make sure that we're gonna run the measurement now and see how close we can get to 28.1 millipascal seconds. So I'm just gonna hit start now. And we're just gonna let this guy run for a little while and let it,
So they can't see it spinning now, but that's all right.
that's okay.
Everything's on the
They
screen.
believe me, I think.
Well, believe you, yeah. This way. Now let's see, it's spinning.
It's speeding up.
Yeah. And at the same time,
Yeah.
it's take the record.
So you can see right here, it's saying measuring,
Mhm.
and then your red line's going across. So when it's done, that'll turn green and solid. Tell you it's complete.
Yeah, I think with manual mode we might have to stop on it.
Okay. So what are you looking for right now? You're looking for this to go where you're.
I'm just watching my viscosity now.
So you're looking at your viscosity, you're trying to match that.
Yes, as
What's
close as
that
possible.
number?
We're 28.1, and
That's
this
pretty
is
good.
28.3. Was
And
for an
the
older
temperature.
standard. The
And
temperature.
also this, the temperature,
25.
25, this was, oh, 25, okay.
Yeah, that's,
So it's a little older, but that's not a big deal. I mean, with the ViscoQC, I think that's within our accuracy ranges. I'd have to check, but
And I think also we didn't really clean the.
yeah, we didn't clean anything. So that's we're on 28 already,
Right.
so that's better.
okay, so I understand this, okay, the speed. I understand the temperature. I'm still a little fuzzy on this right here. Why is it showing us that? What's the significance of that?
So I
The torque.
will have to sit down with you and we'll have to go through that on together.
But just for purposes of this
Mhm.
class right here, where do we want that to be?
We want it to be below 90 and above 10 for sure, if anything.
That's the limit for the mechanic
Yes.
part.
Yes.
Okay.
So how long will you let this run if you were just doing a regular sample and you were trying to get what you wanted? Would you let this run for 5 minutes or a half hour or a day or a minute?
5 minutes. Yeah,
5
I mean,
minutes.
it really depends on the sample and what you're trying to get to.
Right.
So, and like these, it's so stable right now.
Mhm.
Like it's very, very stable. So, I mean, I'm gonna stop it soon.
Yeah,
Everything is stable here.
it's not jumping all over
Yeah,
the place.
so-
The viscosity isn't changing.
Exactly, and that's what you want to see from a standard, so that's good. The standard's not bad, so. I'm gonna go ahead and stop this guy.
That's pretty good. I
And
mean,
yeah, I think that's pretty good. So I'll go in really quick now and just show them different method options and show how maybe even to change some of them around or I'll just show that it's editable
Mhm.
and that if needed, they can work with you and whoever to edit. So I'm gonna go in really quick and just show a little bit of the menu structure, and then also some of the other options for measuring. So I went to menu, and then you can see here data memory, method settings, setup, adjustments, and service. So your data memory, if you wanted to see the measurements that we just made, they're in here.
Mm-hmm.
And so here's your graph. And then here's actually all your numbers. So there's the spindle information, the method information. Say you need this one test, you need it to export it. So what you would do is, right now at the moment we don't have it hooked up to computers, but you could just pop in a flash drive to the back here and hit export right there. And if you hit export, it'll export as a CSV file. And if you are to print, I believe it'll export as a PDF file.
Mm-hmm.
So we'll have Lou go ahead. I'll flash drive here. Okay.
Yeah, it's just in the back.
You guys can see better than I can.
Yeah, I may add an extension cord later,
It's
so
just, yeah,
people
it's
don't have
just like
to
your,
really go
it's
back
just like your
to find
PC.
it.
There's a flash
Yeah.
drive
So
back.
there's 3
You just
USB
stick it in.
ports. So we can do PDF or CSV. And then you would just say target PDF export. And then you would hit, there's your USB there. And then you can rename it if you would like. I think right now it just gives like the serial number, and then it gives you the date. I think 10, 28, 20 at the top.
Mhm.
And then you could just, or you can rename it. And then hit OK, and then that's how you save a data point. So I'll go ahead and save that.
Okay, the question is, if the sample is shear thinning or shear thickening, the viscosity depends on the speed. What's the upper and the lower limit of the speed?
The speed, upper and lower, that's a good question. I'll have to check. It's about 0.01 RPM to 250. So we might, so with this specific sample, we might want to use a different cup and bob because we were at the max shear there, or the max speed, excuse me.
Yeah.
So we might want to play around and see if we need to use different spindles or cup and bobs to get the best speed. But right now, I mean, that's fine for what we need. So it's overall fairly simple. But I'll go back here and go to methods and talk a little bit about your methods. So, so the methods here are if it has an AP in front of it, it means Anton Paar, and those are the preset methods, and they cannot be edited. However, you can pick whatever you would like. So we're going to say, so maybe we want to do, let's see, just program, like some kind of step program. So I just selected it and held on to it, and this popped up. So we have copy, toggle, visibility, or delete. You can't delete these AP functions, but if you wanted to hide them, you could hide them with toggle visibility. But right now, I'm just going to copy it. So once I copy it, it's going to go to the bottom here, and now there's no longer an AP, so I can actually go in and edit this one. So I can rename it there if I would like, and then you can tell it certain steps. So if that stop at time and it has different RPM values, so that might be helpful if you have something that's shear thickening or shear thinning. You can try different speeds and see how it works at different speeds and see how it functions and what your viscosity is like that. And then you can come in here, and if you wanted to put in more restrictions, or if you wanted to put in your density, or if you wanted to have a specific mathematical value model, excuse me, or if you wanted to do things like making your sample name mandatory, or if you wanted to have a density input, if in case you wanted to somehow do a calculation for kinematic viscosity or something like that, that's the density value will give you kinematic.
So it will only like the actual purpose, not really do the calculation.
I don't know if it will. Yeah, I'm not sure. I have to check on that. Sorry.
Yeah, that's fine.
So you can also do speed scan, so that's similar to what I just created with that step program. To stop at a specific temperature, stop at a specific time, stop at a specific torque, or stop at a specific viscosity. That could be useful if you have something that's shear thinning or shear thickening. A temperature scan as well. That's very helpful. If you wanted to look at yield points, that's another thing you could do. And then you can take any of these and edit them as needed to what you actually need for your sample. If you were worried that maybe your level adjustment or something needed to be redone, you can do like I did earlier and go to Menu, Adjustments, Level 0, and then here you get back to the screen. I know I won't go into those right now. I think I don't want to go into too much information or else it gets too detailed. I'm going to go ahead and take this cup and bob out.
Okay. In particular, solvents for
If you want
sample.
I can leave this here so they can see what I do. Any particular solvents?
Cleaning
Well, for
recommendations.
like these oil standards, oil-based standards, you of course would want to use a solvent that can clean oil-based solvent. So I would, something like naphtha or toluene or xylene or even acetone that would clean an organic solvent like these standards. I mean, the solvents, of course, will depend on what your sample is. If you need to know the actual wetted parts for these, if you want to make sure your compatibilities for your solvents are good, that is in the manual, the wetted parts list. So if you had any, normal solvents are not gonna, like you can use acetone on here, it's fine. Even the glass of this guy is Durain borosilicate glass. So if you had acetone in your finger or something or your glove and you touch the screen, nothing would happen, it'd be fine. So I would recommend, for the most part, the only things that are going to be touching the cup and bob or the sample and the solvents and stuff, I wouldn't really worry about everything else. These spindles themselves, so because of that RFID chip, the top of the spindle cannot be, you can't submerge the entire spindle in anything. So I'm pulling out so Lou has it over there and she just has it sitting and she'll be cleaning it.
Yeah.
But
you want to demonstrate
it's
this?
okay. I can use this one. So thank you.
Uh-huh.
So you can totally take this and dink this in something, but you can't dink the whole thing because of the RFID chip. You can't get that really too wet. I mean, if you need to clean it off, I would take a little bit of ethanol or something, or isopropyl on a Kim wipe, and then just dab the Kim wipe on it. If there's something here, if you don't need to touch it all though, then don't. But the rest of it can be wet, but you can't submerge the entire spindle.
So I clean up this, I should also pay attention to not touch this part, right?
Yeah. I mean, if you were to touch it, it's fine, but you just don't dump the whole thing in water.
I see. Okay, yeah. Oh, now I see microchip.
Yeah.
So, yeah. I see.
So that's the only downside with having the information stored on the chip, is that you just can't just throw it into a sink. But like the cup, technically, that's fine. You can clean it however in the bottom of the spindle. So for trimming gas viscosity, not with this guy. This is a baby. That's the best way I can just very low on the rheology scale, essentially. It is just rotational viscosity. It's not rotational rheometry. Maybe on the Rheometer you can do that, but it depends on the Rheometer, and I'm not one of those product specialists, so.
Well, they're the same question.
Yeah.
Yeah.
How can I make sure let's say the spindle is good, in good condition, it's not damaged or scratched or things like that?
Just a visible check, really. I mean, if it's obviously not, if anything on the internal side or on the outside of the actual bob is manipulated too much, you would see that,
Okay.
I don't, like microscopic things, we're not.
So it's not like there is a say self-check or routine we can just hand the spindle there to do the
No, I don't think so. Yeah,
okay.
Not for the spindle itself.
Okay.
If you would see probably unstable numbers
I see.
if you were measuring something and the spindle if it was actually messed up. But for the most part, it shouldn't, even if you have a little scratch on there, because, I mean, because we are dealing with baby viscosity, you know, it's not going to affect it too much, I think.
Okay.
Is there a calibration or something they need to do, like they come into the lab, it hasn't been used for 5 days or whatever, and they want to start it up? Do they need
The level, those things, so.
just the level, no calibration,
Nope.
nothing
I mean,
else?
if you would like to do, there's no like check built into it. If you would like to run a standard or something, so I would, if you're coming in after a couple months of not using it, and when you turn it on, it'll of course go through those level checks and the zeroing of the spindle bearings. And so those are already great things to do. So those are done automatically. And then if you're just unsure, if you're not sure where it's supposed to be at, I would just run a standard, just like any other viscometer. So.
This thing is susceptible to, what is it susceptible to? If I'm, you know, going to mess this thing up or damage it, which
the biggest things, the biggest things to watch out for with this guy is, number one, if you are not using the PTD80, and this is removed, and then therefore you wouldn't be using this guard here. So this guard is making sure that we can't slam the head down. So because as you saw, the head moves up and down. So if this was not on here, and then you had one of these longer spindles on here, and you just slammed it down, then that could potentially, this could hit the bottom, and then that could mess up the bearings in here.
That messes it up. That can mess it up.
So that's the biggest thing, I think. That could easily happen. But other than that, I mean,
I've done that.
If you were to drop it, if you were to, I don't know, or somehow.
This going up and down, and that's the main thing.
That's the main thing, is that this head can move, and
you want to be careful. Just be careful. Yeah. Okay.
So, like I mentioned already, the oil-based solvents, you would want to use something like that for these guys. So right now, you know, we're just running these really quickly. So I would probably go in later, because we still do have a little bit of residue in here, and that's okay, because we're doing our best in that rush time. That I would probably go in with a little bit of acetone later, if you guys don't have any type of toluene or naphtha or benzene, is what I mean by that. And something like that. Like those are benzenes, you know, the top of the crude, you know, solvents that are coming off of there. So like dissolved light, and that would be the best thing to clean out an oil-based solvent. We do work. We do have a lot of instruments such as this that are in the petroleum industry, and when we use the oil solvents, I find that those solvents are the best for that type of thing. So, but for this, I mean, just for cleaning this out, I'd probably go back in later with a little acetone or something and just really get it. If that makes sense. Not having to do with this instrument, I mean, just the normal precautions you would take for any biological sample, probably. Don't eat it. So I'm going to go ahead and load up this sample. I believe, did she mention it was shear thickening or shear thinning? So I would probably suggest to...
It's thinning.
Thinning? Okay. Yeah. Interesting. Good. So I have a little bit of bubbles. So I just try to minimize the bubbles as much as possible. I'm not going to put the bulb in later. I'm going to put it in now. Here it goes. I'm just going to let it rest. And I'm going to pull my head up just a little, make sure I can get it in there. Look at where my little hole is. So I'm going to slide that in. Like that. So that's in there like that. Now I'm going to bring the head down. Yeah. And then here I'm going to get the magnetic coupling, and then just flip. There you go. And then I'm going to push this down.
Or now, when you just put that down right now, you're not trying to touch the bottom.
Right.
How far off the bottom do you want to be? How do you know where to stop that?
Well, for the most part, if I have these pretty much where it is, that should be lining up properly. So we'll do true mode right now, and we'll let it run for a lot longer than we did last time, because I'm not sure what we're going to see. And so I'm just going to hit start now.
What did we say the viscosity range on that is?
It's written in here on Pascal seconds, so it's pretty wide.
On this, on the sample, it's 100.
I think she said 100.
Yeah, it's 100. $100 milli or 100 just.
I think it should be mainly this.
100 millipascal seconds.
Okay, gotcha.
Looks like not that.
Yeah, it didn't seem very.
There it is. It's spinning.
Look at two.
Go ahead.
Oh, okay.
Smaller spindle. So we use this spindle because that's how much sample we had. We don't have enough sample for the bigger one, but it's letting us know that we need to use a smaller spindle. So,
Smaller spindle means that it's too viscous, too thick for that. It's saying it's too thick, too viscous. And it's saying use a smaller one so it can spin more freely, right?
we're on 12 or are we on 18? That one, I mean, that one, since it is going to be using the rheometer, I'd probably suggest you use a rheometer with that sample anyway. Then, because that way we don't have to use more than that amount of sample anyway. If we had a different sample, if we had a little bit more sample that was shear sitting or thickening, that'd probably be better to use, and then show an example with these guys and not the DINs. We would have to go back and forth and continue to clean and have, if we had more sample of that one, that'd be a little bit easier.
Just take a little bit of development work.
Yes.
Is what we're saying.
And that's
That's
normal though. I mean, that's just part of what the deal is with this guy. You know, you do have to kind of go back and forth and see what's needed to get it into the correct ranges and stuff, but at least it's telling you that, you know, at least it's saying, hey, you need to do this. This is exactly what you need to do to get better readings.
So it gave you some suggestions.
Yes, exactly.
Yes.
So.
What is different about this sample that we're just trying now?
So that one is shear thinning. So as it would rotate, it will get less and less viscous.
Right, and that's why this one worked, this one didn't, because they look about the same.
Well, and this one's a little bit
Maybe
different.
we reduce the temperature to 15.
Oh, true.
Let's see how it works.
You're right.
Yes. So maybe it will be in the range, then we don't have to redo anything.
So I guess
We're going ambient, right?
Or should it
I think that means
colder? If the torque is too high, I guess I need to make it hotter.
hot.
So maybe I'll try 40.
No, let's change the temperature to.
Keep the temperature below 35 Celsius, otherwise it will be just normal Newtonian sample. It will be in the isotropic phase.
Okay. So I'll put it on 30. Then.
Oh yeah, 30 or 32, it will be fine.
Okay. So our PTD80 does go fairly fast, so you can see it went from 25 to it's almost at 30 already just now, so it just took a couple of seconds. We'll let it sit though because the measurement, the temperature probe for this guy is on the side, it's not right in the sample, so we're gonna let the sample warm up a little bit then too. So we know that PTD80 is at 30 now, but we'll let the sample take a minute to warm up.
Meanwhile, just I have a question. Do these spindles have the specifications on the viscosity with them, like which viscosity range they can measure each of them?
Yes. So I can make sure that Lou has all of those so that you guys can see those.
Okay.
And another note with true mode, the instrument will always try to get you to as high as to a proper torque as possible. That's below 90%. Yep, so it's at 30, but we're just letting the sample temper a little bit. It's probably almost there though, so I think it'd be okay to go ahead and start it and see how we go. So here we go, one more time. So with true mode, and I'll just add this to, so it will change speeds until it's stable, until the torque is stable for 10 seconds. And then when running in true mode, it'll hold that same speed no matter what. So if the sample is shear thinning or shear thickening, in true mode, just true mode, the speed will not change. It'll just stay there until you stop it. So if you see that the sample is thinning or thickening, then you could stop it, change the speed to a different speed, and see if that will work better. And so then when you do another test, you can then know exactly what speeds will work for the different parts of the process of shear thinning and thickening, if that makes sense.
So you're saying is you can find it thinning or thickening, we basically will carry on multiple measurements at a different speed and then kind of like plot together.
So with true mode, it's just not the best with it. It'll give you a good speed for that specific one. But then I would just suggest what that beginning speed will be, but then as it changes, you might want to do some tests at those different speeds to make sure that those are also giving you good torque and such and good numbers. So, but then once you have that data, then you can go in and make your method so that if you wanted to plot it at different times or different temperatures or whatever, then you could do that then, because you would already have that. You would know then that would give you proper numbers. So we're beginning to run. Here we go. So it's running at the highest RPM. So what it's waiting for is it knows, I think, that the sample is not fully to temperature. So if you see here, that T ready that it's talking about, right there. So it says waiting for T ready.
Oh, okay.
Or ready. T ready. Okay. Let's see.
Different level.
Yeah. A little bit. But at least we're getting numbers now. We're getting a torque. It hasn't started the runtime yet, so it's still waiting for something else. But you can see here that already it's spinning.
Well, just now those kind of warning will be record? No, okay.
It was like, hey, something might be up, and then it was like, oh no, it's fine, and so it took off. So.
I'm not considering that real.
So there's green, yellow, and red. Green means everything's fine. Yellow is just a warning, and then red is an actual error. So the ones that we had before were errors, so those will be saved. And the warnings will be saved as well if they're there by the end of the test, but they're really just there as like, hey, like your numbers are probably fine, but like you might want to look at this and go back and change this. Yeah. So that's definitely giving it stuff. It's at 62.7% torque. It's at the highest RPM again, so it's likely not the best setup exactly for these samples, but at least we're actually getting numbers and we're seeing as it should.
No.
So it'll just run until I tell it to stop right now. But it knows that I think it has an idea that it's not able to stabilize yet because it is doing this. So, but we can see at least that those are the numbers that we're trying to see. But as long as that makes sense, like, I mean, this is, of course, we're not getting a final result right now, but it's because we're just doing these preliminary steps to get to a measurement where we can actually get what numbers we're trying to see. So these are just kind of examples for you guys so that when you are running and testing stuff that, these are just some steps you might want to go through.
The final
One or more average runs. It depends. The final value, it depends on what type of test you're doing. So if you're doing a test where you're just measuring the viscosity at different points, it'll show you that those points. You know, it's not going to give you just one number. It's going to give you a lot of numbers. So the final value that appears on the screen here is what it was just reading last as, but when you go back into your data memory and actually look at that final data point result, it's going to give you all the numbers that you asked it for. If that makes sense? I'm going to go ahead and stop this guy because it looks like we're bottoming out for the most part with our viscosity. So it won't stop on its own anyway. It wants me to stop it too. But so for example, like for that other question, going back to if the final result is the absolute value or the average, it's really, it depends on what type of test you're doing and such. So and right now we haven't really done any real tests besides the one we did. So the one real test that we've done here, we just asked it. So for example, like here's the whole run. You know, we can see all of these points. And of course, for this standard, it was very stable. So it was better to average value. I'm not sure. I mean, I think you can set it up. I think it may be able to give it set up to give you that average automatically, but I mean, it'll give you all your numbers that you ask for. Like if you're doing a table scan of some sort, it'll give you everything. And then you can average them on your own, maybe. If that answers the question, or maybe I don't understand exactly, but overall, I don't want to, use up too much time here. Do you guys understand in the general aspects of how to use this guy? And that it's not just, it is a plug and play instrument that you plug it in and it's ready to measure, but in order to get the numbers that you need for your sample, it might take a couple of tests. It might take a little bit of time to play with it to know exactly what speeds you need and stuff. Yeah, exactly. Okay. So I think that's exactly what we need to go off of here. So, and I'll make sure you guys have the instruction manual is very good. So we'll make sure you guys have that and that you have all the specs for your cup and bob and your spindles. And I think overall, that's you'll have everything you need. So, do you have any other questions, Lou, or anybody else? Looks like we have 2 people.
Yeah. Everyone, if you have any questions, this will be our last chance to ask. I'll make sure I keep them here.
Yeah. And if anybody has questions later too, I'll leave my card so that you can email me and such, and that's fine too. Feel free. It's totally fine.
Yeah.
So,
Thank you.
Thanks everybody. It was nice coming into campus, and stay safe through all of this, and feel free to email me if you have questions.
Yeah.
Thanks.
Thank you. Thank you.
Thank you.
This was fun.
Yeah. So we were all learning.
Yeah.
So I'm gonna close.